Okay, so the recording has started. So now we will go into the session. So I welcome you again to the live sessions of conducted by NPTEL for the course Engineering Graphics and Design. So the course instructors, as you might already know, Professor Dr. Sunil Kale and Professor Dr. Naresh Jatla from IIT Delhi. So introducing myself, I am Vikram Balaji, a research scholar from the Department of Mechanical Engineering at IIT Madras. Okay. So what we learnt in the previous session. So previous session, week 7, we saw about mainly the working drawings and different types of assembly drawings. So we saw there was 3 types of assembly drawings mainly. One is the exploded assembly drawing, one is the section assembly drawing, and another is your normal assembly drawing. So we saw also some example of valve assembly and as example of a knuckle joint in the previous session. Okay, so this session we are going to deal about CAD. So first let me have the laser pointer. Yes, so CAD, computer aided design, is the use of computers to aid in the creation, modification, analysis or optimization of a design. So CAD is one of the many tools which is used by engineers and designers and is used in many ways depending on the profession of the user and the type of the software in question. So CAD can be used to create both 2D and 2D drawings as well as 3-dimensional models. So what is the main purpose of CAD? So the purpose of CAD is to optimize and streamline the designer's workflow, increase the productivity, improve the quality and level of detail in the design, improve documentation, communications, and often contribute towards the manufacturing design database. So earlier, before CAD was invented, so people used to represent their sketches on the paper, and then they used to develop elaborate drawings of different parts. So with the advent of CAD, it has now become easy to generate 3D solid models on a screen, computer screen, and then extract the different types of drawings from it. So CAD software outputs come in the form of electronic files, so which they are accordingly used later for manufacturing process. So this advent of CAD has made it very easier for the design process and the stage from design to manufacturing. So that has been made easier by CAD. So if you see the brief history of CAD development, so in year 1957, we can say that Dr. Patrick Hanratty developed a software called Pronto, which is considered one of the first commercial CNC programming system. So later, 3 years later in 1960, Ivan Sutherland, MIT's Lincoln Laboratory, created a software called Sketchpad, which demonstrated the basic principles and feasibility of computer technical drawing. So this is all 2D drawings. So this Sketchpad is considered one of the first CAD softwares for 2D drawing. So later in the same decade, so many companies started to develop their own commercialized CAD programs. So this era began the formal development of CAD softwares. So these CAD systems, however, they were mostly limited to 2D. So they served as a mere replacement of your paper or a drawing board. So the design engineer still worked in the 2D environment. So they used some basic 2D features like lines, arcs, B-spline, etc. Later in the 1970, a major milestone was achieved by the work of Ken Verspil, who published the first formal description of something called as NURBS. This NURBS is, the full form of NURBS is non-uniform rational B-spline, in his PhD thesis, which formed the basis of the modern 3D curve on surface modeling. So from 2D, we have now come into 3D era. So the basic 3D curve and surface modeling and subsequent development of the part and assembly description language. So this is a software which helps us to model solids. So this software was developed by Alan Greer, Charles Lang, and Ian Braid. Later in 1980s, the Unix workstations emerged and commercial CAD systems like CATIA and others began showing up in the aerospace, automotive, and other industries. Later, a group of programmers formed AutoCAD company in 1983, which released AutoCAD, the first significant CAD program for the IBM PC. So AutoCAD, the advent of AutoCAD marked a very huge milestone in the development of CAD. So later CAD systems changed in 1987 with the release of software called Pro-E, and other CAD programs based on solid geometry and feature-based parametric techniques for defining the various parts and assemblies. So this was one considered a game changer. Later, from 1990 onwards, the modern CAD era has been marked by improvements in modeling, incorporation of analysis and product management, from conception and engineering to manufacturing, sales and maintenance. So this is called as product life management. So not only we are now interested in the design of parts, we are also interested in the incorporation of analysis. So we are suppose doing some analysis. So how the part is subjected to some stress analysis or the temperature analysis. It could be any analysis. And then the product management. So when the product is subjected to its functionality, so we need to manage the product, and we need to ensure manage the product right from its design to the final functionality, and also the sales and maintenance aspects. So this is called as product life management. So this chart you can see the brief history of CAD development. So starting in the 1957. So this Pronto, so Dr. Patrick Henretti is considered the father of CAD actually. So later you can see many softwares have been gradually developed. So we can see that the Unigraphics, Unix were developed. Then you can see Pro-E was developed in the year 1987. AutoCAD was also developed in the 1982. AutoCAD. Then you can see that very many versions of AutoCAD started emerging later. Then you have SolidWorks. Then you have the CATIA. And finally we have the Autodesk Inventor, and then now we are in the future. So you can see so many softwares are there. Now we have different softwares for different applications. For civil drawings you have something called as Revit, like that. So for mechanical use you have many softwares like SolidWorks, Pro Engineer, CATIA mainly for aerospace and sheet metal applications. So and AutoCAD also develops its own software every year. So latest now it is 2023 version has been developed by AutoCAD. Same with the Inventor. So to summarize, we can say that there are four major CAD development stages. So first is the 2D CAD model. So we create a simple models in 2D coordinate system. So which includes geometrical entities like points, lines, arcs, polygons, etc. So one advantage is it is accurate and easy to change the drawings, because we are only working in the 2D environment, so we can easily erase and create new drawings. The disadvantage is that the user has to visualize the 3D object and form the 2D views. So that is one disadvantage. Later the advent of 3D wireframe models came into play. So now we are able to create complex models in 3D coordinate system. But one thing about 3D wireframe model is that it does not define the surface or the volume of an object. So you will see that it is just a network of lines in the 3-dimensional coordinate system. So one advantage is it is easy to store and display. Disadvantage is it is hard to visualize at times. So next we came to the surface model. So now the object is now represented instead of the wireframes. So we are now representing it as a collection of surfaces. So the surfaces are mathematically modeled. So there is a concept called as boundary representation, which is shortly called BREP. So a solid is represented as a collection of connected surface elements which define the boundary between the interior and the exterior points. And this simplifies the visualization by removing the ambiguities. So after the surface model, we get into the solid model. So the solid model, the advantage over surface model is that it contains also the interior details of the object. So how the object is, the material is filled inside the object. So that was not possible in surface model. So in solid model that is possible. So it is based on the principle called as CSG, constructive solid geometry. So primitive solids plus we can model primitive solids like cuboid, cylinder, sphere, etc. And in addition we can also do some Boolean operations. So which is like add, subtract, intersection. There's also another thing called union, etc. So these are the things. Then it has basically two functions. Two features. One is it is a feature based. So to create solids by adding features like holes, fillet, chamfer, etc. So once you create a base solid, we can modify it by adding features like holes, fillet, chamfer, etc. Another thing is parametric. So parametric is nothing but ability to change the dimensions of the object during any intermediate stage of the design. So now suppose we created a basic sketch and we did some operations for creating the solid. So we want to change this solid dimensions, means we can go directly into the sketch environment and change the dimension. So this you will be seeing once we get into the software. So the software as already mentioned in the lectures, So we will be using something called as Autodesk Inventor. So Autodesk Inventor is a CAD application for 3D mechanical design, simulation, visualization and documentation developed by Autodesk. So it has mainly 4 environments. The first is part modeling, second is the assembly, third is drawing and fourth is a presentation. So first step is we have to model the parts. So to model the parts, we start by drawing the sketches to define feature profiles and paths. So we then use commands to apply parametric geometry to the sketched geometry and generate the 3-dimensional part features. Then finally we combine many features to create parts. After we create the parts, we have to then insert the parts into an assembly and create an assembly file. And then we need to use commands to define the relationships, positions and degrees of freedom. So this is assembly. So third part is the drawing environment. Drawing environment helps to create the detailed part and assembly drawings that include multiple views, annotations and dimensions. Then fourth we have as presentation. Presentation is basically, in the last session we saw about the exploded assembly drawing, where different parts are taken away from their positions and shown how they are assembled. So that can be done with the Inventor presentation module. So other than the above main modules, we have some other modules like sheet metal module, some mold design module, etc. So before going further, so we will now see how to, so some people might having the doubt how to install the Autodesk Inventor. So Inventor, you can just type Autodesk Inventor student in the Google. So you can go into the site. So Autodesk Education and Student Access will be there. So have anybody downloaded the software already, or you are yet to download? So can anybody confirm? So have you downloaded the software? Do you know how to download the student version, or shall I explain? Okay, I'll just quickly explain how to do that. So we have to now select this thing. So we have many softwares in the student version. So we need to select the software which is concerned to us. So we are going to see the Inventor Professional. So there is a platform, is a Windows. So this works only in Windows. So we need to click on the Get Started. So I just told how to come to this Autodesk website. So first we have to Google Autodesk Inventor student version and then go to the Autodesk website, and then we have to later click the Get Started. So it is little slow, it is taking some time. Okay, page is unresponsive. Okay, no problem. So once you go inside, so it will ask to sign in. So if you do not have the Autodesk account, you can go to create account. So here you can type what is your country. So it is India. And your educational role, you can if you are a student, you can write student. If you are some educator, you can, if you are a teacher in some college, you can do that. So mostly everyone will be students. So you just type your institution. So either you are in a high school or in a university. So university, fill your date of birth. So let us say some random date I am giving. So let me say that it is 2000. So you have to click next, and we have to give you all your names, email ID, confirm, and then password. So after you create the account, you will be able to directly get into it. So if I already have this account, so I will just directly go into this. So I will type the email. Can say sign in. So after that signing in, you can now go and download whatever software you want. So there are some list of softwares are there. So among that, we need to select the Autodesk Inventor. So this website is slightly slow. So yes, so you say that you have the confirm. So they will confirm that you are eligible for educational access. So the access will last for 1 year. So this is more than enough for our thing. So later we can get the required Autodesk software. So you can start after get product, you can download it and later install it in your laptop or computer. So this is how we have to do. So I will close this. I will now return to the PowerPoint. So I just explained to you how to download the student version of Autodesk Inventor. So if you have any doubt, you can ask me. So if you are stuck in any thing, you can ask later also. Maybe next session when we are telling, you can stop and you can say I am not able to install it. So we can look about it in next session also. Or now also if you are trying in the background, you just try and see whether it is happening for you. So I hope there is no doubt in that. So let us go into some MCQ questions. So before that I will just show you the this thing. So this is the Inventor Professional. So as you would have seen in the lecture, this top part is called as quick access toolbar. So if you click here, you can see that some drop downs are coming. So either you want to do assembly or drawing or part or presentation. So that is there. So if you click file, the same thing will apply. So again, if you have new, so here you can see that there are assembly, drawing, part and presentation. So 4 modules which I explained to you, right? So the first module is part module, second is assembly, third is a drawing and fourth is a presentation. So this I told you just now. So we are most interested in the part modeling, or else you can click this also. Here there is Inventor 2023. You can click the new here also. You can see that some pop-up will come later. Yes, so you can see that this create new file has come, right? So here you can see there are many templates are there. So first of all, we have English, we have metric and we have mold design. So if you see in English, you will have some parts, assembly, drawing. So this is based on the English units. So English units, you can see that it is based on inches. So but we are using the metric units. So you can go to the metric and you can click this standard. So this is the procedure to get into the part model. So once we click the standard, yes, 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 correct. So this is English, right? So metric, okay. Yes. So DIN is also again inches only. So you have 2 things, sheet metal and you have standard. So sheet metal means you want to create very thin parts like 1 mm, 2 mm thickness, means mostly the sheets you can want to do, means you can do. So there are some features for that. But this is what we are interested. So we are interested in the unit. So is it okay? Yes. So this DIN is actually, there is a full form is there, I am not sure, but this is related to inches only. Yeah. So I will just click the create. So it will now go inside the part. So maybe it is because it is little slow, it is taking some time. So it will. Okay. So yes, I think slowly it's coming. Yes. Okay, I think we have now entered. So we have here many things. So top I told you is a quick access toolbar is there. So this is ribbons are there. So in these ribbons you have many things like 3D model, sketch, annotate, inspect, tools, manage. So many environments are there. So below this we have another set of commands are there. So here start for 2D sketch. Then there are some commands. So you just this is the environment, that is sketch, that is part environment. So before going into some modeling, so we will have slightly look at some MCQ questions. So I think this assignment is MCQ related. I don't think there is any subjective assignment as of now. So anyway, we'll look some questions. Okay. So can anybody answer? So which of the following types is or are found in the Autodesk Inventor? So dot is dot ipt, option A, option B dot idw, option C dot iam, option D all of the above. So yes, okay, correct. Yeah. Okay, so this is part, so this is drawing. And this is your assembly. So which means that which of the following is present? Is it any one of them or all are there? So in our inventor, all of them, correct. Okay. Yes, so this is the answer. So we just saw there are many modules. So part module is there, assembly module is there, drawing module is there. In addition to it, there is something called as presentation module. So for this, answer is D. So next answer, what is the use of the extrude tool? So option A is to sketch new features on an object. Option B is to add dimensions to an object. Option C is to grow or cut a feature of an object. Option D, to measure the dimensions. Okay, correct. Yes. Okay. So extrude means basically you can either create a sketch and you can either grow it or you can cut it into an existing object. So this is option C is the correct answer. So again, so another MCQ question. So which option will be more appropriate to create a plane at a particular distance and parallel to a specific plane or surface? So if you would have already seen the lecture, so sir might have already explained. So we will also see later in our session what is these options. So one is normal to plane, option B is mid between two planes, option C is normal, so this option is repeated, option D is offset from plane. Yes, correct. So when you are having already a plane, already an object is there, so one surface of the object is there, so you want to create another plane which is parallel to that surface and it has a particular distance from that. So this is the offset from plane, correct. Okay, so one more question. Figure 1 shows a solid model. So which of the following features can be used to draw the feature which is labeled as part A? So part A, part B are shown here. So is it a loft option? Option B is extrude, option C is rib, option D both extrude and rib. So yes, correct, both extrude and rib. So one option is, so when you are going to draw the extrude, so for example you can draw this triangle part and later you can extrude it in the direction, so you can give the required thickness, so you can able to form this object. So one option. So second option is you can draw a line and you can create the rib option, so automatically it will execute this part A. So that are two options are there, so both extrude and rib can be used. So that is this question. So same object, so for the part B, which option will be used to define the thickness option while using the rib tool? So plane, so we have a plane called B and we have the part called A. So part A is the rib. So whether we are using normal to sketch plane or parallel to sketch plane. So can anybody answer? Okay, so our answer is normal to sketch plane. So this is parallel to sketch plane. Okay, so we will see later. Actually the answer is parallel to sketch plane. So I will tell later why is that option, because so when you are going to sketch, so line will be like this. So when you are going to do normal to sketch plane, what happens is it adds some material over here and it adds some material over here and it connects two things. So you will get something like a rod. So that is what you will get. But when you are going parallel to sketch plane, so you are going to get the full object like this. So I will explain later in the software, so you can be able to see. So answer is actually B. So I will later tell this how this is occurring. Okay, so next question. So to draw a rib, which one of the following type of sketch is required? Closed sketch or single line sketch? So can anybody answer this question? So to draw a rib. Yes, correct. So closed sketch means you are going to draw the full triangle like this, and then you are going to do. Single line means you are only going to draw the slope line. So this will automatically give the rib option. So when you are doing the closed sketch is mostly used for the extrude option. So single line for the rib option, we are going to use a single line sketch. So the B is correct answer. Okay, so figure 2 shows a solid model. Indicate for each of the labeled feature to which category it belongs to among the following options. So option A. So option A is which among the following, which of the following feature is used? So is it extrusion or fillet, chamfer, hole or full round fillet? Yes, extrusion. Okay. So next is option B. So option B is this part. Yes, full round fillet. So full fillet. Okay, correct. So option C. So can anybody answer? Yes, chamfer. So next is part D. Yes, fillet, correct. So next is E. So E is okay, hole. So is it only hole or is any other option can also be used? Yes, okay. Better is go for hole. Also there is a possibility that you can draw the circle, then extrude it, and you use the cut option instead of this option. In the Boolean operation you can select cut option, but better is we can go for the hole. So the hole is a more better option. So part F is nothing but the base of the solid. Yes, extrusion, correct. Okay, so this we have seen. Okay, so once we have seen some MCQ questions, now we can go directly into part modeling exercise. Okay, so before that, so I will show for the rib option alone, I will try to do something. So we'll draw a simple object. So we'll create a line. We'll start from here. So we'll go on along 90 degree. So maybe we can say we are going 20 mm. Then again another 20, we can say we can go for 5 mm. Then say 90. You can come like this. Now again below you can say I am going for 15 mm and 90. We push enter. Then again some 15 mm, 90. Now 5, 90 created here, and now we can finish this. It is now prepared. and click right click and press the OK. Yes, I think now. So is this object, when you see black color means what is the meaning of this sketch? So can anybody tell? So why it is? We saw that the lines are coming in some purple color, but after we finish the sketch it is showing the black color. Can anybody say what is the reason? Okay, correct. So when you are fully constraining, the color changes to black. So I will finish this sketch. So I will apply this zoom all. So now it has now come here. So let us say I am going to extrude this object. So when I click extrude, there is only one sketch is there, so it automatically selects that one. So let us say I want to reverse this thing, flip it the direction. So let me say that I am going to extrude for a distance of let us say 30 mm. So we are getting the 30 mm extrude. You can see the preview also. So let us now press OK. Okay. So again we'll put the zoom all. So now we have created. Now we are going to create a plane. So I want to create a plane, so which is exactly in between this object. So which option should I use? We can use many options, but which is better option? Can anybody tell? Is it offset, or is it parallel, or is it the mid plane? Yes, okay. Otherwise there is one more option. So offset is also correct. So one thing is there is a mid plane. One thing is there. So if we want to do mid plane means we have to select two planes. So first we can select this plane, and second select the opposite one side is there, right? So yes. So if I select this, so it is. Are you able to see the plane which is coming in the middle? So if I click that, automatically the plane is selected. Yes. So this is mid plane option. So as you told, offset is also correct. So maybe if this is 30 mm extrusion means you can select this plane, give the 15 mm offset and get the plane. That is also correct. So now we can start the sketch. Let me select this plane. Go to front. Yes. So it is little slow, so it is taking time. So because of that there is since it is simultaneously recording is also happening, so because of that there is it is taking time. Okay, so let us select this work plane. So the sketch will go to that plane. So automatically we are getting line. Okay. So it will first of all, still the options are in this. So once you go into sketch environment, these options will change into line, rectangle, those things will come. Yes. So you can see that it has changed now. Okay. So for as I told, rip command, should we draw a close sketch or a single line sketch? So we just saw it, we just to draw a single line sketch. So I am selecting a line command. So I am just going to randomly draw the line. I selected first point. So second point is there. I am going to select this point. So I am going to click the right click. I am going to select the OK. So now it is in the purple color, means the diagram is not constrained. So what I am going to do is, so first of all, there is parallel constraint is there. You can see lot of constraints are there. So collinear constraint, one thing is there. Another is coincident constraint. So I am going to make the coincident constraint, select this point and select this line. So now you can see that it has moved to this part. Same constraint, I am going to give this point select this line. So now automatically you can see that this line has been made this. So still we are not having the full constraint. So let me say I'm going to give the dimension. So let me select. Okay. And so this angle dimension is coming. So I want to select the line dimension. So I'm going to this point I should select. So I'm not I think or we can just select this, we can say it is 45 degree, or we can give anything. So if this point I am able to select, then it is okay, but somehow I am not able to select. So this is 48, so let me say this is 45 degree. Edit dimension 45. Okay, now that I have done, again this so automatically 45 means, so this will also be automatically 45 degree. So let me say that I am going to give the length dimension. So you can say this length, let me say that I am making it, so since this was 15, let me say it is some 7.5. Okay, so now it has finished the black color, so which means that it is fully constrained. So I am going to finish the sketch. Okay, so now we have this thing. So again this line, arc, circle, so it will now go, and now we are going to get the the 3D features. So let me say that I am going to select the rib. So there are two options, right? One is normal to sketch plane, this is parallel to sketch plane. So let me see if I am going to select normal to sketch plane means what I am going to get. So if I select this thing, so thickness, okay. So are you able to see the preview? So it comes like yes, okay. So let me give OK. So this is normal. So create rib creature failed, you can see, right? So I am not able to give the normal. So let me say I am giving the parallel to sketch plane. And now so now you see, so it is coming like this, right? So we saw the question, this one, right? So for the labeled section B, which plane option will be used to define the thickness direction? So now this doubt is clarified, right? Why it is not normal and why it is parallel. So any doubt is there now? Clear, right? So this is not, so somebody answered option A, so actually answer is option B. So that's why I showed this example. So let me say that I am going to click this OK. So now this part has been added. Yes. So later if I want to hide this also, I can able to do. So this work plane, I can right click. I can, is there anything for hide? Let me see. Export object, repeat, new sketch, measure, visibility. I can take off this. So now I have the plain object only. So first let me save this. So let me go to some folder. Let me create a new folder in this desktop. So let me say I'm naming it as week 8. So inside that, yes, I think this very slow, so it's taking a lot of time. Okay, so we can name this part as rib. So I have showed you one example why the normal to plane does not work. Okay, so this we will now close it. Okay, I think it is still not saved. So we will now go to home. Okay, so meanwhile this gets loaded. So yes, it has renamed to rib. So now we have come back to home. So let us close this. Yes, and we will now see the question we are concerned. Okay, so can anybody say what is the first step we are going to do? So we have this object, right? So first, okay, anyway, so first thing I have to model the base, correct? So what is the total dimension I have to see now? So total is 75. And what is the height? So this is a front view. This is the top view. So from top view, so for the height, so for the base we need to see from the top view. So what is the width? So length is 75, width will be, so this is R15, right? So we can do the 2 times. So radius of 2 times 15 is 30 mm. So we have to draw first a base which is 75. So you see that this is the 75 length and this is the 30. Okay. So first we will draw this. Let us say now we are going to open new one. So it is a little slow. I think because of that it's not coming properly. Okay, it came. So again we are going to select the standard mm, click the create. So now it will go into the part module. So okay, so we just saw that our we need to first create a sketch of a rectangle. Okay, so I think we have now come. So let me start the sketch. So let me select this base plane, which is the XZ plane. So now we come here, we select the rectangle option, we click this point. So 75, 30. So we click this, click the zoom all. So we have created the 75 cross 30. Let me finish the sketch. So now again let me put the zoom all. So now we got the 75 cross 30. So now we need to extrude this. So can anybody say what is the height? So it is mentioned here the height is 9 mm for the base. Okay, so I click the extrude. So automatically only one sketch is there, so it selects. So let me say that I am extruding it upwards by a distance of 9 mm, and then click OK. I got this solid. Next option, I have these two cuts. So what option should I use for this cuts? Yes, correct, chamfer. Okay, so chamfer, if you see that chamfer is 9 mm, 9 mm is there. So this is 9 mm, this is 9 mm. So this edge I am going to chamfer. So let me select this chamfer option. So first let it, this is the environment load. Yes, we got this. So I have three options. One is equal distance. So another is one distance and one angle. Another is two distances. So two distance means when sometimes this, say let us say this is x is 9 and this is y. So if x and y are not equal means that time we can use two distance formula. If you have maybe one dimension and you know the angle which is let us say 45 degree, so then you can draw the one dimension and angle. So now we have both are equal, so we go the first option. So only one distance is there. I'm going to select this, replace with 9 mm. And I'm going to select the edge. This is the edge. So once it evaluates, you can see that some preview will come. So it is loading. Yes, you can see that same distance this both will be. So let me click OK. Then the chamfer will be applied. So now let us go to the other edge. Same chamfer I am going to apply there also. Yes, we came here. Same chamfer, same 9 mm. I am going to select this edge. So again preview I am getting. Let me select the OK. So again we got the chamfer. Okay, so next is I have to draw this square, right, and I have to extrude it to full. So it in the top it will see like this edge is there. So what is this distance so from this edge to distance we need to calculate what is the distance, so that we can take the help of this one. -60 minus 18, right? 60 minus 18, so that will be 42. So this dimension will be 42. So from this edge to this center it is 60, and from the center this is 18, so it is 42. So let me go, I'll first create a plane. So first let me come to the home view. So it will come back to the normal view. Yes. So now I'm going to create a plane. So now I'm going to use the offset command. Offset from plane. So from this edge I'm going to select offset of 42. So I'm going to flip the direction. So I click on this. So I think it is going somewhere inside. Okay, I click OK. Okay, I think one work plane, if I select this. Okay, so now let me start the sketch. in that work plane, or I can, yes, I have to select this work plane. So I think, yes, I am in this sketch part. So let me once, okay, I'm not sure in which plane I am, so let me first exit and then I will properly select. Okay. Okay. So first I will delete this sketch 2. Start 2D sketch. So select the plane. So I am going to select this work plane. Okay. So I think I'm in that correct thing. So I'm going to sketch it. So what should I sketch means I have to sketch the rectangle. So this rectangle, this width will be 30. So this will be 30 and the top height will be 30 minus 9, which is 21. So this will be 21. So 30 cross 21, I need to draw a rectangle. Okay. So rectangle, I'm going to select this point. So yes, 30. So what was the height we calculated? It was 21, right? Yeah. 21 cross 30. Let me enter. Okay, so it is, since this base position already fixed, so again we can see that the rectangle is constrained. So I give the zoom all, so we can see that 30 cross 21 it is constrained. Now I am going to finish the sketch. Okay, I think it has offset this side. So I think we need to, okay, so work plane was created here, so I will delete this again. I'll delete this work plane also. Okay, I have to create other side. Offset, I select this one. .42. So I think to flip it, I think I have to click somewhere here, I think. Or let me say I'm going to click minus 42. Now I got here. Okay. So no problem. So now I can create sketch in the work plane 2. So now I'm going to create the rectangle. So again, since now we have to wait for the options to come. Yes, so I will now come to here. Let me click. Again 30, 21. I'll click zoom all. So I will now finish the sketch. Okay, now I got correctly. So now I have to extrude it. So let me click this extrude. I have to select, yes, so this plane is selected. Okay, so I have to now switch the direction. So we can see there are three options are there. So through all, if I select, let us see where it is going. I think it is going much beyond it. Or I can select this two and I can select this face. So automatically 33 mm is being calculated. So let me click OK. Yes, so I got this. So next what I should do? So to get this round, now what option should I use? Can anybody tell? Yes, correct. So let me go to this view. Okay. Yes. So I'm going to go to in the fillet. There is down arrow, so I select the full round fillet. So for full round fillet, I have to select side A, center face, and side B face. So this is my side A. This is going to be my center, and this is going to be my side B face. So now I got this automatically. So I click OK. So I get that fillet. So next is I have to create this hole of diameter 15 mm, and the center of this hole is concentric with respect to this arc. So let me give the whole option. Yes, so type, so I will select this face and have to select this. So now automatically the center of this hole is now aligned with this arc. So now my diameter, what was my diameter? It was 15, right? So 15 mm diameter, yes, dia 15. Now it is through all, I think so. So this is through all feature, and I am going to click OK. Direction is also fine. Yes, I have clicked the OK. So now if I see the top view, I will be able to see the hole. Yes, so now I think everybody is able to see the hole. So next I will go to home view. There is, I think, one more feature is there. What is that feature? So we will use rib option for this. So we need to create a line. So exactly in the mid. So we create another plane, midpoint between two planes. So first is this plane, second is that plane. So now I created a mid plane. Now I am going to start a sketch in this plane, working plane. Yes, select it. What is this distance? this distance, this distance. So I'm going to create a line. Directly I'm going to these 2 points. So up till the green color comes, I have to wait. Yes, now it has come. Up to another green. If it is green color, if the yellow color turns to green color, yes. So now automatically it is constrained. I click the right click and do OK. Yes, and now I finish the sketch. So I have now created this line. So now I have to use rib option. So it is 7 mm. Okay, so rib, where is it? It is rib. Okay, I'll click the rib option. I already explained, right? It is should be parallel to the thing. So why it is coming fully, I don't know. I think some sketch, I think there is some mistake is there. Oh, why is this line coming? I'm not sure. Okay, I'll delete this sketch once again. I'll create new one. Okay, so now I'm going to create a sketch, start a sketch in this plane. So now I'm going to start a line. Yes, so select this. Yes. So now let me finish the sketch. So why this is coming? Okay. So let me give the rib option. Profile is, I have to select this. I think both are getting selected. I don't know why that is happening. I think now the rib is coming. So it was 7 mm. Both side equally spaced. Okay, so let me give the OK. You got the solid finally. Okay, so I will hide these two work planes. Work plane 3 I will hide it. Visibility 0. So that work plane gets hide. Now I will hide this also. So finally we have made the solid. So I think this is fine, right? So I'll save this. I'll say this is some bracket. I will name it. Okay. Then I can save. So I actually added two more examples, but since there is no time, so I will just mentally I will just walk through this example. So first step is, so can anybody say what is the first step? So first we need to identify these dimensions, right? So yes, if you see side view, this is 25, this is 60, and this is 30. So this 30 mm, and then so if you can see, this is the front view, and this is the left side view. So this top view is front view, here it is right side view. Right side view, I think they are looking from here. Okay, so if I look at front view, the base is 110 mm, and this thing is 60 mm. So 110 by 60, I am going to draw a rectangle. Okay, if time permits, we can try this example alone. So let us say this is 110, this is going to be 60. Okay, so I will create a new, I will go to home, I will click on the new, so another file, standard, I'm going to create it. Okay. So now start the 2D sketch. I am going to choose the base plane, which is XZ plane. So I am going to draw 110, 60, 110, 110 cross 60, right? Yes. Let me go zoom all. Yes, I have now drawn that. Let me finish the sketch. Again I click the zoom all. So like this I am getting 110, 60. So I am going to extrude this. Meanwhile this, let it load. So this height I have to extrude it. This height is 30. So I have to create a 30 mm. So preview will change. So I click OK. I got the extrusion. Again zoom all. Yes. So now I am going to create this cutout. So the cutout is, how we are going to say, it is 40 mm by 25 mm cutout. 40, this 25. So 25 is from the base. So from this base to this base 25, and this 40. So I am going to sketch on the top plane. (25, 40). So I am going to draw a rectangle 40 cross 25. So let me draw first randomly. So it is 25, 40. Yes, so now again I press zoom all. It is unconstrained. So I am now going to constrain it. So for to constrain it, I have to specify the location properly. So first of all, I use one command called this command is there, right? Collinear constraint. So I can cause a collinear constraint means this line and this line. If I am going to make it collinear means it will fall on it. So now two are constrained. Now two more is there. So I have to specify this 35. So if I give the dimension of this line and this line, it is now 22 something. So I am going to give 35. Now it is fully constrained. Finish the sketch. Create the cutout. So to create the cutout, I am going to give the extrude command. So now I have to change it to Boolean. I have to make it into cut. So automatically it detects the first surface 30 mm. So I'll give through all. I give the OK. So I created the cutout. Now I am going to add 4 chamfers. So all chamfer is 3 cross 45 degree. So quickly I will do all 4 chamfering. Chamfer. So mm and angle is given. So I will give 3 cross 45. I'll select this edge. Okay, this edge I am not. It should come edge, right? Or is it face? Okay, I think it is face. Is it like this? Yes. So now, yes, I click OK. 3 and 45. So again, I click again chamfer. So we have 4 chamfers. So 1, 2, 3, 4. Okay, chamfer. It's very slow. I don't know why. Okay, so same 345. First I select this face and the edge. Yes, preview came correct. So okay, another chamfer. Same thing, face, edge. Okay, so let me click. So 3 chamfers I added till now, I think. So the chamfer is created. So here 3 chamfers already created. Next, same thing, 3 mm and 45 degree. First this face and this edge. Okay. Okay. So chamfer, 4 chamfers I have now created. So next thing is I have to create this this thing. So the dimension, if you see 30 and this is 80, so this will be 50, and this total will be 110, and that distance will be 20 from this side, this plane. This will be 60 minus 25, which is 35. So this will be 35, this distance. So at the distance of 35 offset, I am going to create a plane. Offset. This one. So let us see which direction it is showing. So it is showing this direction, means opposite side I have to go 35. So let me put minus 35. Okay. So I got this thing. So I have to sketch in that plane. I select this work plane. So I click the zoom all. So now I create a rectangle. I pick this edge. Yes, it has been picked. I'm going to create a 110 by height 50. I think it automatically will constrain. Yes. Zoom all. Finish sketch. Okay, now I'm going to extrude. I can give the extrude command. So we'll choose this sketch. So let me say that I'm going to flip the direction, and I'm going to give up to surface to next. Let me see what happens if I give to next. It is giving the 25 mm. Yes, it is automatically detecting at 25 mm. So let me click OK. Okay, it is failed, so it is not able to detect that. So I can give two surface. So I can click 2. I'll flip the direction. Let me select that face. Maybe this option will work. Yes. Okay, so that I have done. Next, fillet. Fillet is radius 6. So I'll go to normal fillet. Select, I'll give 6 mm. Select the edge. Okay, 6 mm filleting is done. Let me do this also. Same, I select fillet, select this edge. Okay. Yes. Getting the fillet. Okay, so that is also been filleted. So now we are finally left with 2 holes. So one, you can see that there are same thing, dia 6 is through hole and dia 12 is up to 5 mm. So let me create a hole. So I think spot face counter. Okay, this is the hole, clearance. Okay, so now I'm going to give diameter of, so which is through hole is, first I will give the dia 12 hole up to 5 mm. So dia 12, termination, I can say distance. I'll give the distance. So I'll give the flat 5 mm. Now I select this face. So one thing is there. So I select this and distance, is showing 36. So ideally this distance should be 30. Now I select this edge. Oh, I think I've already created the hole. Okay. I go to this. Yeah. I have to edit it. So dimension. Select this hole and I select this upper part, upper edge. That should be so. Why is it not coming? Okay, I didn't select dimension. So this dimension should be 25. Yes. Now I will finish the sketch. Now is it updated? Yes, now it is updated. So again I have to give another hole inside. So now I have to give a through hole. Again hole. So now I am going to give a through hole. So diameter is 6. So I would select this face. And it has to be concentric with this. Yes, so now it is concentric. So now I select OK. So 6 mm through hole, and now give. So if I see this from the right side view, let me see if I am able to look through. Yes, so now we are able to look fully. So that hole has been created. So instead of creating another hole, let me try to mirror the thing. So I will now select a mid plane about which I am going to mirror this whole feature. So this plane and this plane. So I am going to use the mirror option. So where is that mirror? See the whole fillet. I think it's circular pattern, and this is mirror, I think. Yes. I'm going to mirror features. I'm going to select this holes. Hole 1. Mirror solids, mirror individual features. Mirror plane, work plane 2. Feature, hole 1. So why it is not mirroring? Okay. To select this feature. Yes. How to select that? I will select this hole directly, and if possible I will select this also. Okay, hole 1 I will select. Maybe yes, hole both I have selected. Let me give OK. I think I have got it. Okay, so we have finished this solid. So this work plane 2, I am going to hide it. Visibility, I have taken it out. And similarly this work plane 1 also, I will take out the visibility. So we will now see the object. I think we have completed the object. There is nothing remaining. So let me save this. Okay, this mirror plane, this plane I will again have to features. Work plane 2. I have to. Oh, it is visibility. It is already invisible only. Oh, work plane 3 visibility. Okay, now I hide it. Okay, now I have saved the object. Let me say this is another bracket. Some parts maybe part. I will save it. Okay, so I think it's already time. So we have done 2 solids. So is there any doubt in these 2 solids? I actually prepared one more, but I think we are not having time. So we will now close the session with this. So it is the end of the slideshow. So does anybody have any doubts in what we discussed? So how the features I am applying. So quickly I will have a small recap of what we saw today. So we saw what is CAD, the history of CAD, and Autodesk Inventor, then some MCQ questions. So I think in the MCQ question we saw this difference between normal and parallel to sketch plane. We saw that we have to use parallel to sketch plane to get the rib. So we saw these MCQ questions. Then we saw two part modelings. So is there any doubt in what we discussed? It's clear, right? Okay, so we can close the session now. So if there is no doubt, we can close the session. So thanks for attending this. So have a happy weekend, everybody. Okay, so I will close the session now, and I will stop the recording also. Yes, thank you. Yes.